This is a geometry video, and our topic is exterior angles of a convex polygon. Yeah, that's important that we make sure we understand the definition of convex. And while I am using regular polygons to go through this video, they don't need to be regular in order for this to work out. It's just easier to use regulars. So just keep that in mind. Okay. Now let's look at this regular triangle to begin. And what I have here is a little hide show button to create these extended sides. And one important fact about an exterior angle of a polygon is we only want to extend one side, which then gives us a linear pair. And there's another video about linear pairs. Come on, marker. We have an interior angle, and for a regular triangle, this is always 60 degrees. And our linear pair exterior angle, we can use some deductive reasoning, some subtraction, and get 120. And we can then apply this, to all three exterior angles. So remember, when we have three interior angles, we have exactly three exterior angles. And each linear pair is going to be 60 interior, 120 exterior. All right, now, for the sum, and I'm going to use a little subscript e here to mean the sum of the exterior angles. We have 120, 120, 120. 3 times 120, which is, that's a 0, 360. So sum of exterior angles of a triangle, and we can be more specific and say a regular triangle here, is 360 degrees. Okay, let's move on to a square. This would be true for any quadrilateral. Square is nice and easy, though, to work with. So I've extended the sides again. And remember that when we have a 90-degree interior, the exterior always has to be supplementary, because these are always forming a linear pair. So we have a 90 and another 90, 2 more 90s, 2 more 90s. So let's just look at the exterior. So the sum of the exterior angles is going to be this 90 plus this one plus this one plus this one. 4 times 90, and what do we get? 360 again. Moving on to the regular pentagon. Come on. I also extended these sides so that we have exactly one exterior angle for each interior angle. And who knows the interior measure of a regular pentagon? You got it, 108. So if our interior is 108, what's our linear pair? Let's see, 180 minus 108 gives us 72. And that will be the same measure for this interior and this exterior. Let's just focus on the exteriors. Each exterior angle will then be 72. Now if I want the sum of the exterior angles, 5 times 72 equals 360 again. Nice pattern forming here. Now we're not actually doing a formal proof here, but we are going to hopefully have a good way to remember this theorem when we're done looking at this video. And let's extend the sides of a regular hexagon. The interior angles of a regular hexagon are 120, which gives me an exterior angle of 60, another linear pair. So 120 and 60, let's just focus on the exteriors. All are 60 degrees. How many exteriors? The sum of the exterior angles, we have 6 of them, which again is 360. Okay, I'm hoping that this is sinking in. Now, a regular octagon, we could extend the sides. Now for this, I want to show you that sometimes it's easier to start with the exterior angles. And let's go ahead and take a look at the actual formulas. This was from a previous video. The interior angles, and this little I right here, this little subscript, is just to make sure that you understand that we're talking about interior angles. Okay, you won't always see that subscript for this kind of formula. But this was our formula, the number of sides minus 2 times 180, and that always gives us the sum of the interior angles. And this is for any convex polygon. Doesn't have to be a regular polygon. Our new formula doesn't get much easier than this. The sum of exterior angles is always 360, no matter what, as long as it is convex. So using that formula, let's start with the fact that the sum of our exterior angles is always going to be 360, no matter what kind of convex polygon we have. This is an octagon. So if I want a single exterior angle, I'm going to divide this by 8. Right? Each vertex will yield one exterior angle, one interior angle. So 360 divided by 8, who's good at math? We get 45 degrees. So that is one exterior angle. So I can go in here now, and since this is regular, it means that all of these exterior angles will be congruent to each other. 45, 45, and what we can do here is work backwards using what we know about exterior angles to then figure out what the interior angle will be. So what's our linear pair with 45? 135. So this is another way to figure out that each interior angle of a regular octagon will be 135 degrees.